This is hydrogen bonding and how it kind of works and interacts. So you want to draw multiple pictures here. So the first picture you want to draw is just of a whole bunch of water molecules just being around each other. And so here we have a whole bunch of water just coming into the screen. And notice that each water molecule, and you want to draw this, has an oxygen end with its negative area and its hydrogen end with an absence of negative or a positive area, and that's because the oxygen has a cluster of electrons around it due to its 8 protons in its nucleus and hydrogen only having 2. So the water molecule is a polar molecule. It's got a slightly negative end at the top where the oxygen is and a slightly positive end at the bottom where the hydrogen is. So if we bring another water molecule next to it, it's going to align itself accordingly. So it would never, even if it came in like this, notice the two pluses are together, and the water is going to say, no, that's not going to work out. So we're going to flip around, and the negative end of one is going to attach to the positive end. Not attached to, but be attracted to the positive end of the other. And that occurrence is also going to happen over here. Negative end of one to the positive of another. And notice here we have an H and an H, so we could slide the oxygen end of one right in here, and that's going to fit. Okay. Around the top of the molecule where we have an oxygen up here, we could slide a hydrogen end in here, kind of like that. That allows us to slide another oxygen end in here, kind of like this. And finally we could slide another oxygen end in here. It's going to cause these to push out a little bit because we have the hydrogens here and they're going to push out, and we'd have to slide an oxygen end in here. And another oxygen end in possibly here. So in general, we need to know that the negative end of the water molecule has an attraction for the positive end. And notice how all these water molecules will be vibrating around, and they will be together, and they kind of are confined to this space. Okay, so that's water. Water is relatively dense, 1 gram per milliliter. Now, as those water molecules, so we should have one drawing of this, okay, or something close to this. Now, as these water molecules slow down in a freezer situation, okay, and stop shaking, we create a situation where hydrogen bonds are allowed to form. So currently, these molecules in regular water, the water molecules are moving, so the hydrogen bond isn't allowed to form per se. And notice we've got 1, 2, 3, 4, 5, 6, 7, 8, we got 9, and we'll go ahead and put 10 water molecules in here. You bring that one in like that, and notice they're kind of confined to this space. Now watch what happens when we freeze them. So this was one drawing, here's your next drawing. When we freeze water, we basically slow all the particles down until they almost but not quite stop. And when that happens, we allow a hydrogen bond to form. And so we're going to represent hydrogen bonds with our little bond lines that we bring in here. So there's one water molecule, and we're going to hydrogen bond it, this H to this O here, and then off of, put it like that, off of this H here, we're going to hydrogen bond to another O here. And off of this H up here, we're going to hydrogen bond to another O over here. We could also hydrogen bond off of this hydrogen to another O over here. And we could come down here and we could hydrogen bond to that O there. We could drop another hydrogen bond in here, out to another water molecule over here. And we could come down here. And be aware that my hydrogen bonds are not perfect by any means. The intent is to show you that water, when it slows down and is frozen, okay, is allowed to form these hydrogen bonds. And notice in this picture, we've taken up almost the entire page or entire screen. And we've got 1, 2, 3, 4, 5, 6, 7, 8 water molecules. So we've got 8 water molecules and a bunch of little hydrogen bonds locking them together. The thing to notice is that these 8 water molecules take up much more space with the hydrogen bonding than the previous picture that we drew where they were all kind of shoved together. And this is critical to our world because this is effectively a picture of what water looks like when it's frozen. Okay, most things when the particles slow down, the molecules involved come closer and closer together. Water does not act that way. Water actually forms hydrogen bonds when it gets cold or freezes. And this is the reason why water expands when it freezes. So if you've seen the water bottle in the freezer or the soda bottle in the freezer and it expands when it gets colder, that's due to hydrogen bonding. This is critical in our world because if you think about solids, liquids, and gases, ice floats in water because of hydrogen bonding, whereas most things, as they get more dense, they would drop to the bottom of the column. Or as they go from a solid to a liquid to they go from a gas to a liquid to a solid, they become more and more dense. Okay, water is counter to that due to its hydrogen bonding. Water is actually most dense as a liquid and less dense as a solid. This property allows ice to float in water, which is really, really critical to our existence and life on our planet. And so that's a little bit about hydrogen bonding. You should have 2 pictures drawn. One without the hydrogen bonds formed. You could label that one water. Okay, and then this one with hydrogen bonds formed, and you could label this one ice. And you need some note in there to note that the regular water without the hydrogen bonds is more dense than the ice that does have hydrogen bonds. And finally here we'll just summarize some of our bonding types and kind of what they mean. We don't have a picture of it. We've talked about ionic bonding between like an Na plus ion and a Cl minus ion where an electron is transferred. We also talked about quite a bit about covalent bonding where electrons are shared, and the relationship between the O and the H here is an example of that single bond where electrons are actually shared between the H and the O. This final form of bonding that we talked about is hydrogen bonding, which is another type of electrostatic attraction similar to, but not the same as the Na plus and the Cl minus, but electrostatic meaning plus minus attraction between the negative end of the water molecule up here and the positive end of a nearby water molecule here. So we've got an electrostatic plus minus attraction there that develops when that hydrogen bond forms. So 3 types of bonding that we discussed, some with similarities but all distinctly different, and those are ionic bonding, covalent bonding, which involve interactions between inside of a molecule, and now this new one, hydrogen bonding, where we're talking about interactions from one full molecule to another molecule. So a little bit different. So all things to be aware of and think about. The differences between ionic bonding, covalent bonding, and now this new idea, hydrogen bonding.